Okay, so we're going to start our next unit on simultaneous equations. So I'm going to start off with just a pictorial description as to where simultaneous equations come from and how you use them to solve two or more equations at any one point in time. So the aim of simultaneous equations is they often have two or more variables. For GCSE, you just need the two variables, and you're aiming to solve what the value of each of those variables are. So if we have a look at the diagram here, you can hopefully see that I've got 3 hexagons and 3 squares, and they're equivalent to 9. And then on the bottom one, I've got 3 hexagons and 1 square, and that's equivalent to 13. So you could try and work out what each of the shapes are worth just from looking at the diagram, but I'm also going to show you how you can set that up algebraically. So if I call each of our hexagons H and each of our squares S, then I would have 3 hexagons and 3 squares, and they're going to be equal to 9. And then on my second diagram, I've got 3 hexagons and 1 square. Okay, so you could put the 1 in or just have S for square, and that's equal to 13. And actually what we want to try and do is eliminate the things that we've got in common in both things. So I can get rid of that hexagon and that hexagon. I can get rid of that hexagon and that hexagon and that hexagon and that hexagon. Okay, so 3 hexagons can actually disappear from both equations at that point. I can also get rid of a square from this one and a square from this one. Okay, now what I need to think about then is I've got nothing left here at this point, but I do have some values left. And what I've actually done is taken away everything on the bottom set from the top set. So I'm going to put a big subtract sign there, and I'm going to do it like we would if you were just doing column subtraction. So I had 3 hexagons and I've taken away the 3 hexagons, so I have no hexagons left. I had 3 squares and I've taken away the 1 square, so I've got 2 squares left. And I had 9 and I've taken away 13, so I've actually got -4. And if I simplify that, I know that my 2 squares are equal to -4, and then I can divide by 2 to work out that 1 square must be worth -2. Okay, and then if we think about the fact that we can use that information to try and work out what the hexagons must be worth. Now you can do that in either of the two diagrams. I'm going to go with the bottom one. Okay, so on the bottom one, I've got my 3 hexagons and my 1 square, and we know that must equal 13. But I actually know my 1 square is worth -2. So my 3 hexagons, take away 2, must equal 13. And then I just need to solve to try and find what the hexagon is. So I'm going to add 2 to both sides. That will leave me with 3 hexagons must be worth 15. And then I can divide both sides by 3. And I will end up then that 1 hexagon is worth 5. And you can check it in the other set, in the other diagram or the other equation at that point. So I know I've got 3 hexagons, so that's going to be 5, 5, and 5. Add them together and I've got 15. And then I've got 3 squares worth -2, so -2, -2, -2. So 15, take away 2 is 13, take away 2 is 11, take away 2 again does in fact give me 9. So that's how we can do it in terms of a diagram, but I want to focus more because the skill that you need is more linked to being able to do it with algebra. Okay, so I just want you to have a look at these 2 questions. See if you can think about what you could see or what you could do at this point, and then hit play when you're ready for me to go through it with you. Okay, so what we're going to have a look at on this one is these 2 equations are very similar in terms of the method. So I'm going to make sure that you're watching carefully and making notes on this one, and then we'll have a look and make sure that you can solve them. Right, whenever we're solving simultaneous equations algebraically, we have the 2 equations. We always want to label them equation 1 and equation 2. Just saves us a little bit of time when it comes to writing things down. Okay. Now what we're looking for is to try and see if we have the same number of variables in terms of the equation. So I've got 2 single x's in both equations. I've got a y and I've got 3y. So my x's are in fact the same. So I'm just going to highlight them because they're the bit that's really useful at this point. Now, what we need to do is to make sure that we understand how we can eliminate the x. So you can either add or subtract. Now, because you want to get rid of the x's, you're going to have to subtract them. Now, the quick trick rule for this is if the signs are the same, we subtract. Okay, and as I say, we do that like we would do the column method. So what we can do is just draw a line underneath it, and everything in the top line, we're going to take away everything in the bottom line from it. So I've got x, take away x. That's gone, that's 0, that's eliminated, that's exactly what I wanted to do. Now be very careful next. I've got positive y minus 3y, and hopefully you'll remember a minus and a minus really means that we need to add them. So it's then y add 3y, that gives me 4y. And then I've got 11 take away 7, that gives me 4. Then to solve to find y, I divide both sides by 4, and I end up with y is equal to 1. And at this point, I need to use that to find out the x value. So we substitute y equals 1 into one of our equations. And it's totally up to you. It doesn't matter which one, but I often would say have a look at them and think about which one you think is the easiest. For me, I would say in this case, equation 1 is the easier one. So I've got x plus y equals 11, but I now know that my y is worth 1. So I've got x plus 1 equals 11. If I subtract 1 from both sides, I end up with x equals 10. So my solution at the end, and I'll always have an answer for both the two letters that are involved in the equations, is x equals 10 when y equals 1. And again, you can check it in the other equation. So equation 2 we haven't used. That's going to be x is 10 minus 3 lots of 1. So 10 take away 3 does in fact give me 7. So if you're doing an exam question on this, you can always self-check and make sure that you have it correct. Right, so let's have a look at question 3. So again, the first thing that you need to do is label the fact that you've got equation 1 and equation 2. Okay. And this time, if I have a look, I've got 7x and x. They're not the same, but I've got a y and a y. At the moment, don't worry about the fact that one's positive and one's negative, but they do go with the y's. So I'm going to highlight them that way. Okay, and then I need to decide whether I want to add or subtract the two equations together. Now remember, when we looked at question 2, I said if the signs are the same, we subtract. Well, looking at my two y values here, the signs are different. So if the signs are different, then we're not going to subtract. So signs are different, we then add. Okay, so that's your trick way of trying to remember. So I'm going to pop the add sign here. Now remember, the whole point is we're trying to eliminate the ones that I've put in the box so that I can get rid of them, and it makes my life much easier for solving. If we're not getting rid of them, then something's going wrong. Right, if we have a look then at these two, so I've now got 7x add x, that's going to give me 8x, minus y add y, that's going to give me 0, okay, which is what I wanted. It's eliminated the y's. And then 16 add 8 gives me 24. So 8x is equal to 24. I now need to solve it this time to find x. It doesn't matter which one we're finding because we'll find them both at the end. And therefore x is equal to 3. I then need to substitute this into one of the equations. Again, for me, looking at it, I think equation 2 is actually the easiest one. So therefore, that's my x plus y equals 8. But I currently know x is worth 3. So it's 3 plus y equals 8. Then to solve, you would take away the 3 from both sides to give you y equals 5. So your solution at the end is x is equal to 3 when y is equal to 5. And again, you can check it in the other equation. So equation 1, 7 lots of x, so 7 times 3 is 21. take away the y value of 5 does in fact give me 16. So 21 take 5, it gives me 16. So again, you know you have got that one correct. Okay, and we're going to have a look at one slightly harder one. So this one is where things look a little bit different. So again, just have a quick look at this question. Think about what you do to start off with, and then hit play when you're ready for me to go through it with you. Right, okay, so hopefully you've spotted the fact that I've got 3x here and 5x here. They're different. I've got a single y here and a 2y here. They're different. I'm still going to start by labelling the fact that I've got equation 1 and equation 2. But I need to try and get either the x is the same or either the y is the same. Okay. Now, to get the x is the same, I'm going to have to do something to both. But I can make this y into a 2y by doubling equation 1. So this is why the notation of labelling them 1 and 2 makes life a little bit easier. So equation 1 needs to be multiplied by 2. And you have to do that to every term in the equation. So therefore, if I times the 3x by 2, I will get 6x. If I times the y by 2, I will get 2y. And if I times the 16 by 2, I get 32. So make sure you multiply everything by 2. Okay, it doesn't have to be 2 because in certain questions it could be 3, could be 5, could even be negative something. Okay, so multiply everything by the value that you need to, which was 2 in this case. I'm then going to write, so that's still my equation 1, but I've multiplied everything. I'm now going to write the other one underneath it again. So that was my equation 2. And this time, my 2y's are the ones that I have the same of, which is what I manipulated it to do. And my signs are the same. So my signs are the same. I'm going to subtract. So I've now got 6x take 5x. That's going to give me 1x or just x. 2y take 2y. That will cancel out, which is what I wanted. And 32 take away 26 gives me 6. Okay, so I've quickly solved that one. I then want to substitute my x equals 6 into one of the two original equations. And again, just think about which one's the easiest. I'm going to go with number 1 in this case because I've only got a single y to deal with. So I'm going to pop it into equation 1. So it was 3x plus y equals 16. X is worth 6, so 3x is 3 times 6. That gives me 18. Plus y equals 16. And therefore, if I subtract 18 from both sides, I end up with y is equal to negative 2. So my solutions at the end are x equals 6 when y equals minus 2. Okay, and I can double check it again in the other equation. So 5 times 6 is 30. 2 times minus 2 is minus 4. 30 minus 4 is 26. So you can double check it. Okay, so what I want you to do is have a look at all of these. You might want to watch it through twice and just make sure you're happy. But the key bits of information that I would say you need to take away and highlight in your notes at this point is if the signs are the same, then we make sure, so same, we're going to subtract the two equations from one another. And if the signs are different, then we will end up adding the two equations. Okay, and remember that's the things that you've got in the box, the things that you've highlighted, so you make sure you're looking in the right place to do that. So signs are the same, subtract, signs are different, add, and you will eliminate one of the letters at that point and make your life much easier when it comes to solving. So remember, if you're not cancelling something out, then it's likely to have gone wrong somewhere. Do be very careful when you've got to take away a negative. Remember, that makes a positive. So that's really important as well. Okay, right, have a look at the tasks set.